All right, so let's take care of the last two examples in not only the section, but the chapter. So for this first one here, those numbers there represent the age in weeks when babies first crawl, based on a survey of 12 moms. We are going to assume the population is normally distributed. So first thing, pause the video, enter that data into your calculator. So then compute the point estimate. So remember that will be the mean for the average age at which a baby first crawls, as well as the sample standard deviation. So in this case, you're just going to need to do a one variable statistic on that set of values that you put in there, back to like one of the very first things we did. We will determine that X bar is 38.25 weeks, and the sample standard deviation is like 10.001 or something, so we're going to go 10.0 weeks. Construct a 99% confidence interval for the mean age. So again, go to your T interval, okay, T interval. We're going to use the stats. Then your list is where you put them. Again, I'm assuming L1, frequency of 1, 99% confidence level. And we end up rounding to one decimal place, 29.3 to 47.2. Okay, and then for the interpretation of that, there's a 99% chance the true mean age at which babies crawl is between 29.3 and 47.2 weeks. Okay, and that's all there is to that one. All right, so moving on to example 5, the last example here. So a Gallup poll of 1,006 Americans asked, how many books did you read at least partway during the last year? The survey results indicated X bar was 13.4 and the sample standard deviation was 16.6. So make a 90% confidence interval for the average number of books people have read. So this time we're still using our T interval, but because the information was given to us, now when we go over to our T interval, sorry, I got to get to there, T interval, we want to use stats this time. Okay, so for our input, we want to use the stats because we already have the summary. So go ahead and hit stats. Then you're going to get an input there for X bar. That would be the 13.4. The standard deviation is going to be the 16.6. N is the sample size, so the 1,006. And that confidence level of 90%. Okay, go ahead and calculate. And again, rounding, let's go to one decimal place. I'm getting 12.5 on the low end and 14.3 on the upper end. So the interpretation of that would be there's a 90% chance the true mean number of books read is between 12.5 and 14.3 books. Okay. Construct a 95% confidence interval and interpret the results. So again, if you go back into T interval, everything's going to be the same. Just change your confidence level to 95%. Okay, and again, I want you to think for a second what should happen if we go from 90% confident, think of that target, to 95% confident. What should happen to that target, to that interval? Okay, it should get bigger. So if you change that 90% to 95%, We end up with 12.4 on the low end and 14.4 on the high end. Okay, the interpretation is exactly the same as part A, except we're going to change 95% from the 90%, and we're going to be between 12.4 and 14.4 books. Okay, everything else again stays the same. So again, just some questions to help make sure we've got this connection between confidence levels and sample sizes and what happens. So when you raise the confidence level, okay, so when your confidence level itself increases, okay, what does happen to your confidence interval? Okay, your confidence interval again widens, it gets bigger. If you want to be more confident, you want a bigger target. As your confidence level increases, what does that do to your margin of error? Well, again, if you have a bigger and bigger target, you're allowing yourself more room for error. So the margin of error increases or gets bigger. Okay, moving on to D. Let's say instead of surveying 1,006 people, we can surveyed 5,006 people. Make a 90% confidence interval using those sample stats. So go back into your T interval, the test that we've got there, and this time change your N to 5,006. You can leave the 90% confidence interval from the previous question, okay? At this point, we've got 13.0 on the low end and 13.8 on the high end. It does not say we need to interpret it. We've done 2 interpretations. That's enough. So what happens when we increase the sample size? So if N gets bigger, what happens to the confidence interval? Okay, notice your confidence interval narrows. In other words, the more people you ask, the more accurate your results have gotten. And so you don't need such a big target, okay, because you've gotten better and better and better results. Also, as increases, if your confidence interval is narrowed, you've gotten better and better and better results, you are shrinking that, so that means your margin of error decreases. Okay, and how could we increase our confidence level? Okay, so we want to go from 90 or 95 to 90% or whatever without widening the confidence interval, okay, without having a margin of error that changes. So remember, if we want to do that, okay, normally if we increase our confidence level, we're going to have a margin of error that gets bigger. To counteract that, we have to use a larger sample, okay? So we're going to need to increase the sample size. That's what counteracts the increase in margin of error. All right, that's the end of chapter 8. So head for the 8.3 homework and see how it goes.